This is an overview of the Programming a MIPS Core software class. This class covers software topics related to MIPS Technologies cores. It is tailored to meet the needs of software engineers who are not familiar with MIPS cores or the development tools offered by MIPS. You will be given an in-depth view of MIPS-specific programming needs for system programmers. That includes programming the caches, TLBs, exceptions, boot code, and more. The Software Tools section gives a brief description of the software tools that are available for MIPS cores, such as compilers and debuggers, common OS packages that you can use, co-simulation solutions provided by our partners, software simulators, and our hardware evaluation system. The Instruction Set section covers the MIPS 32 Release 2 instruction set. It does so by breaking down the instructions into two types. First, a machine instruction, which is directly defined in the MIPS architecture and has a one-to-one correspondence with a single instruction bit encoding. And second, there are macro instructions. These instructions are supplied by the assembler to make the assembly coding easier. These instructions can be simple aliases to a machine instruction or translated into a series of machine instructions. The assembly language section covers the usage conventions for the 32 general purpose registers, synthesized instructions, assembler optimizations, common macros you can use, and the function calling conventions. The MIPS architecture has a very defined way in which the CPU views memory. The memory map section will go into the MIPS privileged resource architecture. In this architecture, the CPU view of memory changes depending on what state the CPU is in and how the addresses are being translated. This section covers the memory map with a TLB or translation look-aside buffer, the memory map with an FMT or fixed map translation, and the class will go into what the memory map looks like at exception time and boot up. It will also go into a simple example of a system memory map. The next section will cover the translation look-aside buffer or TLB. It will cover what the TLB is, how to initialize the TLB including a programming example, and an example of how TLB exceptions are handled. In the exceptions and interrupts section, the class will cover what an exception is and what exceptions are generated by a MIPS core. Then the class will go into specific form of an exception called an interrupt. The class will go into two different interrupt modes, vectored interrupt mode or external interrupt controller mode that can be used to access interrupt code. This section will also cover an interrupt example that uses the general purpose registers and one that uses shadow register sets. The cache section of the class will cover the dimensions of the cache and what make up the size of the cache, how things are looked up in the cache, what types of cache policy you can set, what non-blocking loads are, initialization code for the cache, cache management such as cache flushing, what virtual aliasing is and how to avoid it, what the prefetch instruction does, and cache exceptions. The CPU core boot up section of the class gives you a coding example of what needs to be initialized for a MIPS core. Power is a factor of the clock frequency. The lower the frequency, the lower the power. The Power Management class section shows you coding examples on how to regulate the clock frequency by the use of a CP0 control register to control an external pin interface or through the use of a wait instruction. In the Porting a C Program section, we will cover Indianness, what is it, a review of caching issues, odd data alignment, the use of short variables, warnings about the use of typed character in your code, and the use of bit fields.